Hey traders, let's talk about moving averages. Let's write one up really fast. Moving averages, that's what we're going to be working on here. So first thing when you work on something, you got to do your data. We'll set that as the close. Prices, input our length, 20. So when most people write up a moving average, let me just show you what it usually looks like. There are two ways that you'll see this. Define the SMA number 1. The very first way that most people will write this up will be to call the platform functions for a moving average. Which will look something, depending on the platform, this could look different. And for ThinkOrSwim, it looks like this. So that would be the first format. You have some function that's taking inputs and outputting your simple moving average. The second way that you'll see often is to take the sum of the data at the length and divide by the length. That's a common way to see it as well for a simple moving average. The way that I'm going to do it's a little bit different. I'm going to allow for a new tool called coefficients. Now, what's useful about coefficients is that we can change this SMA to make it a little bit more robust. So in an SMA, let me just really quickly show you. If we have a price, we have prices, and we have price 4, price 3, price 2, price 1. And we take these prices and you say, what's the average for these? What you're going to do naturally is you're going to add them up, right? You say price 4 plus price 3 plus price 2 plus price 1. And then you divide by the count, right? 1, 2, 3, 4. So you divide by 4. What you don't realize that you've done here is you made an equal weighted moving, well, average. It's not moving. How did you do that? Well, each one of these you weighted with the value of 1. You multiplied each one by 1. And the way this works is, I'll show you the way it works. So you'd say each one was weighted by 1. So we could say this. We could say A times P4 plus B times P3 plus C times P2 plus D times P1. Now, if this is equal weighted, what we're going to divide by is the sum of the coefficients. So we're going to divide by A plus B plus C plus D. And what will happen is if A, B, C, and D are all 1, then we end up with this formula here, which is just the simple average. And what makes it simple is that the coefficients, which is when you have an x, most people use to x as a variable, and you have a coefficient. A coefficient is what's being multiplied by your variables here. So we have an equal weighted or a simple, and that's what it's simple. They're all 1s. Now, if I took and instead of 1s, I said, well, let's for some reason make this one heavier, right? So I'll change my here. So let's make this one heavier. You could do. Let's see. I want to do this in colors that can make sense. So we'll do right here. We'll write P4 plus P3 plus P2 plus P1. Now let's say you wanted to make 3 heavier. So let's make 3 10. And it's much heavier than its buddies over here. So we'll make this one worth 3, and this one worth 3, and just for the heck of it, we'll make the first one worth 1. Then when you go to attempt to turn this into an average and divide, what you need to do is make sure that you're adding up these coefficients. So it would be 1 plus 10 plus 3 plus 3. And what'll happen is this one will be worth more. And the way I sort of think about this is, if you think about it, what you're multiplying across here versus what you're dividing is really equal to 1. You need to make sure that your coefficients always equal here. If you get these numbers all screwy, some programming platforms will crash your computer. So be careful about. You need to make sure your coefficients always add up. You always add up all your coefficients to equal 1. Anyway, so we've made this p equal more, but the whole thing ends up equaling what we multiplied across it is going to be equal to 1. I don't mean the p's, if you take the p's out. So now I want to show you how to actually do that what we just talked about using code. So you can see right here this moving average and this one, both are, the sum of the data are equal weighted. Their coefficients all equal 1. Now the way I like to do it is we'll create a weight, and we'll make it 1, just because this is 1. And now we need to create a weight sum. If you remember, at the under the at the bottom, we had a sum, and we need to find the weighted data sum. So we'll say total sum of weight coefficient times data, the variable here. Now what we need to do is create the summation, or the moving average. So we'll say define the SMA. We'll do SMA 3. So the numerator, we're going to do weighted data sum minus weighted data sum, and we're going to index that at the length. And then on the bottom, we'll do weight sum minus weight sum. Okay, so this is what it looks like to inject coefficients onto an SMA. Now we'll plot that. This should come out to be the same as this simple moving average. But what's great here is that we now have this little variable to deal with. This weighting that is a 1. It's a 1 right now. So it should be an SMA. So I'll plot them both. I'll plot that one and this one. Now, one feature that I'm gonna put on right now that's important is this. I mean, I can write it in a few different ways. I'm gonna write it in a different way because I think it's gonna make a little bit more sense. No, I'll just use their function. And what this is gonna say is if we are 20, we're the length from the beginning. Don't give me some crazy numbers, and I'll show you in a second. Okay, so this compound value is going to help make the SMA look a little bit smoother. Okay, so you can see there's only one plot here. So our plot, the one with the coefficients of 1, looks exactly the same as the built-in simple moving average. Now, here's where this gets really cool. Simple moving average is okay, but we want to take a look at other variables of the bars. There's a lot of variables. We have tick count, we have volume, you could look at volatility, you could take like a standard deviation where you have like a Bollinger Band or something, grab the, if it's at the low of the Bollinger Band, or if it's near the middle, or any data that you think is a good weight. Any data that you want, you could use as some sort of weight here. Now, a lot of you are familiar with VWAP, which is the volume, which is grabbing this one, weighted average price, volume weighted. So here's our weight. Why don't we give it a test? Let's put volume in here and see if we can get a volume weighted average out of this. So we'll select our weight, and instead of making it equal weighted or 1, which we could make it 100, it doesn't really matter, it's equal weighted, it doesn't change. Let's make it a variable weight, like volume. Let's see what changes. Oh, look at that. So I will plot the subgraph of the volume so that we can see, there's the volume, why we get the bars we got here. Okay, so what's happening here is in that summation, you can see that our volume spiked up here, and it made this more relevant. And you see how it pulled the data away from the simple moving average. Same here. It pulled it away. It's because these were weighted more heavily. You remember, P1, if you have the volume here, and the volume is, 1,000 on this bar, 10 on this bar, and then you divide it by, you add those up, so it's 1,000 plus 10 plus 10. This one's going to matter a lot more, and that's exactly what happened here. This huge volume spike dragged this volume weighted average down, and then as they cooled off, you can see so did this. It started to go back to what it was doing before. So as long as all the volume is consistent, it's actually pretty, similar to a simple moving average. So it's going to show you weighted there. So so we can do other things. We could take the volume out. We could actually make this an input, right? So let's take that and make it an input, and we'll add it to the top here. Now we could come in and ThinkOrSwim has a couple of inputs. Maybe we use one of these, volume, VWAP, open interest, implied. Some of these might not make a whole lot of sense. Let's do tick count. So we do tick count, very similar. The tick count will go along with that. So our simple moving average now is a little bit more responsive. One of the problems that it's still struggling with, and I'll scoot this down so you see the formula without having to look at, there's the way that I did it. One of the problems it's still struggling with is the length here is another feature that we can adjust. But that'll be a video for another day. So what this here is, it's coefficient weighting. You can put anything you want in here. It's recommended that you normalize. You don't have to, but I like to normalize. When you can use volume, your tick count, anything you want. Will make that change the weighting instead of being that equal weighting. Or you could just have it be 1, and that'll be your simple weighted moving average. I hope that was helpful, and that can help make you guys better traders. If it does, let me know. I'd love to see the kind of things you do with it, what kind of tools you can come up with. This is one of my favorite formulas for writing averages and things like that. So have a great weekend and good luck trading.